In this video, we're going to take a look at the alternate form of the limit definition of the derivative. Now, typically our definition of the derivative allows us to find the function of the derivative, which will then allow us to find the value for any, the value of the slope of the tangent of any point along the equation or the graph. The alternate form allows us to find just the derivative at a single point. And the function looks very similar. If we take a look at the equations over here, we're still looking for the slope of the tangent, only instead of looking for the tangent as our h, or our change in x, approaches 0, we're looking for it as x approaches c, which is that value we're trying to find. And so if we take a look at the diagram that we were using earlier, we've got our arc here, our f of x coming up along the curve here. And what's happening is we're looking for the value as our x gets closer and closer towards c. And so we actually have values for both. We have the value of x and we have the value of c. And so when we put it into our symbolic notation for the derivative, instead of using a variable in there, we're actually using the constant, or the value of c. So the derivative, or the f prime of c, as the limit of x approaches c of f of x minus f of c is equal to c, over x minus c. I got a little ahead of myself. So if we're plugging this in, we'll go ahead and give you an example here. This is our f of x is equal to x cubed, and we're looking for using the alternative form in order to find the f prime of 3. So we're going to go ahead and write this up. We've got the limit with our notation here, limit as x approaches 3, and we'll write this as our x cubed minus, that's our f of x, minus 3 cubed, okay, that's our f of 3, and that's all over our x minus 3, okay. Now we go ahead and if we take a look at this and just try and do a direct substitution, you'll notice that this ends up being 27 minus 27, or 0 over 0, gives us an indeterminate, so we need to go ahead and simplify this. Hopefully you're a little familiar with the difference of cubes, and so what we end up with is trying to derive the factors of this difference of cubes. So I'm going to go ahead and rewrite this here. X cubed minus 3 cubed over x minus 3. So we'll go ahead and do the difference of cubes. Now, if you're familiar with the format, or the pattern for that one, then you can just go ahead and fill it in. But if you're not, division of polynomials is going to be your answer. So this is our x minus 3 being divided into, we've got our x cubed. We have no x squared values, so that becomes 0x squared. We have no x values, and then we have our minus 3 cubed, which is 27, I believe, minus 27. I got carried away with the 3 there. So we'll rewrite this, minus 27. As we're filling this out, we start with our first term, and it's x cubed divided by x. That's going to give us x squared. And so the x squared putting in here becomes x cubed minus, I got a little carried away again. Should pay more attention to my signs. So minus 3x squared. We'll go ahead and subtract this out. That's going to give us 0 here, and this becomes a positive 3x squared, so we have 3x squared. So we bring down our 0x, and we do it all over again. So 3x squared divided by x is going to give us a plus 3x when we divide it out. Sorry, I should probably show that over here. So our first one is x cubed divided by x It gives us x squared. The second one is 3x squared divided by x. Same thing. This is the first term of the two binomials. That gives us 3x. So we put our 3x up here. We multiply this through. That's going to give us our 3x squared in the first term, and a minus, looks like 9. 3 times negative 3 minus 9x in the second term. We can go ahead and subtract that. Signs change. This becomes negative. That clears out. This becomes positive. So we end up with a 9x minus 27, because this comes down. 9x divided by x is going to give us 9. And so that goes up here. It is a positive 9. So this becomes 9 times x, or 9x, minus 9 times 3, or 27. And so when this subtracts out, we're left with nothing. So we can simplify this equation now by looking at it as the limit. This would be x minus 3 times x squared plus 3x plus 9 all over x minus 3. The two denominator terms come out, so now we've got x as it approaches 3 of x squared plus 3x plus 9. At this point, we're just plugging in the values, and so this becomes 3 plugging into x squared is 9, plus 3 times 3 is another 9, plus 9, and so that's going to give us a value of 27. So what we know from this alternate form of the derivative is that the value, or the derivative, of f of x at 3 is going to be 27. And that's how we do it. Again, this is only going to find us information for a single point as opposed to the entire graph, but it can be useful in certain occasions, and it does sometimes show up on the AP test.